This is code.org. Let's see what we're doing. Investigate, modify, run the program and observe the results. All right. 6 found at index 2. Then experiment with the program by making the modifications one line at a time. Look at the binary search method in search.java. What do you notice about the code? All right, guys. So first, a binary search. What is that? I'm going to magic my way over, to a previous lesson, this one, and this is a binary search. Now, I added some print statements here to allow us to view the content of it, but a binary search is where we are considering the left and the right side of content and using the midpoint to identify where to look next or possibly find the item we are looking for. And so for a quick refresher, let me magic my way over here, right? This is an example of a binary search. For example, I'm searching for the number 27. That would be at index 5. So in a binary search then, we are going to say, okay, we're going to get the first number, index 0, and the last number, index 9, and say, all right, and then we want the midpoint, right? So 0 plus 9 is 9, divided by 2 is 4.5. But casting that to an integer, we get 4. All right, so then we're considering 18. Is 18 more or less than 27, the number we're searching for? Well, 18 is obviously less. And what that means, and this only works because these are sorted, right? It is least to greatest. Since this is sorted, it means goodbye. We can just kill off this entire part and ignore it, like we do right here. Well, now we need to grab a new lowest index. That would be this one. New highest index would be this one, and a new mid index would be this, 54. And then what do I say? Well, 27 is less than the middle index, 54, so goodbye to that. We can kill that off. Now we have the least index is still 5, bloop. Our middle index, though, would now be 5 as well, and our high index is 6. Why is the middle index 5 as well? Because, again, guys, we would have 5 plus 6 divided by 2, which would be 5.5. But in Java, since we use int, it will end up being 5. And we just found the middle index is what we're comparing, 27. So we have seen how to do that with a traditional loop. Now we're going to do it recursively somewhere. There we are. All right, look at binary search method, and what do you notice about the code? What we notice is that it's recursive. So, and by that, a recursive method is a method that calls or runs itself over and over again to accomplish its goal. That is what is occurring here. So right at the top, we say if left is greater than right, yeah, that would be a problem, right? If for some reason our left pointer was here and our right pointer was over here, we have an error. We need to stop going. If it's greater than that, we return -1, meaning we never found that number. Else, or actually not else, otherwise we're just going to keep going. Middle is left plus right divided by 2. The target, the number we're looking for, if the target is less than the middle, right? So if 27, right? If 27 is less than the middle, that's what I did right there. If the target's less than the middle, what do? We binary search again with the left number being the same, right? Because if this is less than the middle, we would leave the left pointer here. And then the middle, we subtract 1. For the right, we say, it's the middle minus 1, because we don't need to concern the middle. And then we're searching for the same target. Otherwise, meaning if the target's greater than nums at middle, which is what I had here, well, in that case, we still need to pass nums, our number array. Middle is going to be equal to, or left is going to be, the new left will be equal to middle plus 1, which is what I did here, right? The new left was 27 because we know 18's less than. The new right is, just kidding, right stayed the same, the high stayed the same, and the target would also stay the same, 27. If we have found the middle, we return it. So this will rerun the method. Now, when I call this, it goes bloop. Okay, numbers are the same. Middle, like I said, right here. Middle is now, or left is now middle plus 1. Well, for me, that would be 5. So left would now be 5. Right would be the same, which was 9. And we go again. Is left greater than right? No. The middle, left plus right. Okay, well, 5 plus 9 is 14. Divided by 2 is 7. So middle is now 7. See? And is number at index 7, 54, less than the target? No, 54 is not less than my target in this example, 27. Else if target 27 is less than 54, yes, that is true. So num array, middle plus 1, what was my new middle? No, wait, if target's, no, this is true. 27 is less than 54, so left stays the same. Right is going to be middle minus 1. Well, my middle was 7, so my new right or my new high is 6, and the target. And then we go back around, loop through the midpoint of this, like I said, would end up being 27, so we would return 27. It's the same goal accomplished, except without a loop. Create a new 1D array containing several values. Call binary search to find a value in the list. Okay. I'm just going to do copy. And actually here, they want me to do, I'm just going to copy it all, whatever. Control C, blah, blah. A new list. Just make sure your list is in order, right? So I'll do like a 5, I'll do a 7, a 9, 11, right? You have to have numbers that would be sorted already. So 22, 55. They have to be pre-sorted for this to work. And then I'm going to search for, I don't know, I guess 22. And nums, my nums, sure. I'll call mine result and Grabau. Cool. Onward.